Welcome to VMblog's coverage of KubeCon CloudNativeCon 2023, taking place in Chicago. Today, I have the pleasure of having Laurent Gil, who's the co-founder and chief product officer at Cast AI. Welcome.
Thank you. Nice to be here with you guys.
Well, maybe you can start by telling us a little bit about the company and kind of give us a quick overview.
Yes, of course. So first, hello from Miami. This is where I'm located now. Very excited to speak to you and to speak to your audience. What Cast AI is very simple. If you use a cloud and you use Kubernetes on the cloud, then we will reduce your costs by at least 50%. It will take 5 minutes. That's what we do.
Yeah,
it's cool.
Yeah. Obviously, we're here today. We're talking about the KubeCon CloudNativeCon event that's coming up. Explain a bit, if you would. Just talk about how your company fits within the ecosystem that's being discussed at the show. You know, why an attendee would be interested to come learn more.
So thank you. This is a great question. We were, before Cast AI, on the other side. And that's the reason why we started the company. So I'll tell you the story. My previous startup was a cybersecurity company. We got acquired by Oracle. Great outcome. But here's what happened. We started in 2015. We used Cloud Native, the very early beginning of it. Spent $1,000 a month, $2,000 a month on AWS. That's normal. We have 10 engineers. We're developing the product. By the time, or let's say by 2018, the time Oracle and us joined forces, that number became $1.2 million. And you can imagine this was the highest cost, compute cost for us. And we never really understood what to do about it. Meaning, of course, when you spend that much, you receive 100 pages, more than 100 pages, a bill from AWS. It's normal. You pay for the services you consume. But the question has always been, do we need all this? And maybe it's even more than that. Do we need all this at any point of time? Like at night, our customers are sleeping. Why are we spending that much when no customer is being secured by us because they're sleeping at night? And so there was all of these questions that we never really got answers with. And that's the reason why I started Cast AI. And the reason why I'm so excited with KubeCon is precisely because we were in the shoes of all these DevOps engineers and developers trying to make Kubernetes work. Kubernetes is fantastic as an idea and fantastic to scale applications. But it's very hard to understand whether your compute resources in your cloud account are the one you need to run those applications. And the answer is they are not. And that's why we started Cast AI. And there's no secret, there's no magic. Why are we saving 50%-ish for our customer? Precisely because it is so hard to understand and make sure that whatever you use for CPUs and memory is what you need. And then with a very strong feedback loop, so every few milliseconds or every few seconds, you can have an automated engine that asks that question and that take action in real time to ensure that you do follow the utilization curve of your application and you don't over-provision it. So that's what we do. And that's why I think it's very relevant. That's why I'm always excited to go to KubeCon. I was there in April in Europe. I will be there in November in Chicago. I really look forward to it because these are all our peers that have this issue and we can help them.
Now, talking about how, this is a very heavy Kubernetes event. For attendees, what are some of the specific problems that Cast AI solves for them, and maybe go into some of the specific use cases for Cast AI?
Yeah, there are three very difficult things to know with Kubernetes. One is, if you need to add, let's say you have a bunch of containers They just appear because your application is scaling up. And so you need to add compute resources for these new workload that just appeared in your cluster. Question is, which one do you add? The answer is, oh, I always add the one I know. But the one you know may not be the most cost-effective right now. So we built an AI engine that knows this, knows exactly the availability in the availability zone where you operate, whether it's AWS, Google, and Azure. And I will always select the most cost-effective additional compute required to run the application. But it does more than that. It also knows, oh, this workload is actually very stateless, so it doesn't use a lot of storage. It's a very dynamic workload, so it goes up and down very fast. Oh, that's great for use of Spot Instance, which is these highly discounted instances on any of the 3 cloud providers. So the engine will say, well, in this case, I'm going to use this one because it's a lot cheaper than on-demand, even reserve instance, or even whatever you have on savings plan. You see, it's impossible for the human to know this. But if you use some clever AI engine that is fully automated, then you can do pricing arbitrage in real time with all the instruments that the cloud is giving you from Spot, from reserve instance, or from savings plan, or from on-demand sometimes. So that's one thing it does. The second thing is, it says, well, I have these 100 VMs. It's called a node in our language, Kubernetes language. So I have 100 nodes. Do I really need 100 nodes? And the answer is always, absolutely not. In fact, the amount of CPU that you require is often 40%, 50% lower than the amount of CPU you have. Great. So we trained the engine to say exactly this, to say, oh, what do I need? What do I really need to run this? And once I know that, then I will only provision that. You see, that's easy when your app is growing up because you add cost-effective nodes. When the app is going down, let's say it's night and your users are going to sleep, so you don't need all this workload. Then the question is, which one of these nodes can you get rid of? Do you start by the most expensive one? Do you start by the one that will have zero impact in performance? Again, it's reason why we use automation. It's impossible for the human to do this in real time. I will show you an example of this, so you see exactly what it means. But the point is following the utilization curve and doing this in real time, whether you're going up or you're going down or you're in the middle and it fluctuates. You want to make sure you supply what you need, nothing less, because then you'll have a performance issue, but nothing more, because then you overspend in your account. And then the last one is one I'm super excited with, which is the following. In Kubernetes, where containers work is the developer has to say, I think this container uses 2 CPUs. And so they say, okay, it needs 2 CPUs. We will supply 2 CPUs because the developers say it needs 2. But the question is, are you really sure it needs 2? And so all of these 3 strategies are the things that we are helping our users to handle in a fully automated way. And that's why the savings is so high. It's not high because we don't know or we're not great at managing. It's high because it's impossible to do it by hand.
Now,
that's why yeah. Go ahead.
There's that was a great rundown of the use cases. Thinking about your technology, obviously there's the KubeCon event has well more than 200. I think it's over 250 vendors that'll be on the expo floor. Thinking about your technology, what is it that you think makes what Cast AI creates and puts out there? What is it that makes your technology unique or differentiated? It sounds like at least part of that is what you talked about is your AI.
And that's exactly it, David. It is, and more than AI, I would call it's automation. How we do it, yes, we use AI, we use Smart Engine and a bunch of other things. but it is the automation. You see the FinOps industry or the cost optimization industry traditionally has always been around recommendations. Oh, you need to shut down this because you don't use it. Oh, you should change this 100 machine by these other 100 machines. These are recommendations. We don't do recommendations. We implement. It takes time to understand it because we keep saying, no, we are not providing recommendation. We replace recommendations with automation. With us, yes, we will show you these machines has to be replaced, but we actually change them for you. And by the time we do this, we're changing others because of this real-time feature of automation. And that really is what differentiates us. There are not that many players in the automation space. A few of them that I really appreciate and like with my colleagues in other places. But this, I think, is the future of how you manage infrastructure for those complex things that is Kubernetes.
And, historically, KubeCon is a great place for companies to announce what's new and what's happening. What are some of the new things that Cast AI might be, telling people about at the show?
Oh, you're gonna see some very, very cool features that are all about making this more autonomous. There are things that you should believe. Hey, would it be great that I tell an engine, I want to right size? Please do it for me. I don't know how you do it. I just want to click the box that says, make sure you right size in real time. The act of making Kubernetes management fully autonomous is what you're going to see if you come visit us. We're going to make some big announcement. And unfortunately, I cannot tell you what they are because they're going to be announced at the show. But I can tell you that the theme of this is going to be some extraordinary impacts of using automation. I'm telling you now, we are saving an average 50% to our clients. I think that number is going to be much higher with making these systems more autonomous.
Well, we definitely, we'll come by the booth. We want to hear more about what you're alluding to here. Thinking about the show as well, we know on the keynote stage, they're going to be talking a lot about big picture items and futures. What are some of the big themes or trends that your company is interested in as we head into 2024?
Yeah, there are a few that I really like. So there is a very nice project from AWS called Carpenter. I like it because it follows the same philosophy and principle that we have. And frankly, the more we are into pushing the automation for managing infrastructure, then the better place it becomes, right? So I really like what these guys are doing. I frankly really like what the GK team is pushing. And I can't wait for looking at some of their sessions that they are going to have at KubeCon. My excitement in terms of Kubernetes is more linked to some new features that Kubernetes is having. One of them is a little bit technical, but one of them is the fact that you can resize containers in real time without having to restart them. Imagine you have a container that uses 2 CPUs, and you say, well, it doesn't really need that, or it needs more. It needs 4. Usually when you set the number to 4, then that container collapses, kind of reboot and resurface. And the new version of Kubernetes will make this in real time without this rebooting thing. And that is going to help a lot to make more things automated for Kubernetes. It's a new version, so it will take some time to be there or to be used. But I'm really excited by the open source community to continue to push this to the extreme. It's a really good community to follow also. A lot of good colleagues.
Well, and I guess lastly, you kind of alluded to it earlier that you might be able to give us a demo that shows some of these things that we've been talking about. Would that be possible?
Yeah. So what I'll do is I'm going to show you a before and after. So you see exactly what happened and what were the strategies that the AI engine decided to use for, it's a real use case from a user. It's a real cluster. And then I have some deeper dive on some statistics that I want to show you of between before and after, including for some AI company that start to use Cast AI. So what you see now is our platform. What you see actually is our monitoring platform. You see this customer is spending about 345 days, $350, $360 per day on this cluster. So very, very typical cost monitoring tool. What I'm going to show you, and this is last month, and you can see here, they shut down the cluster, and the cluster restarted on the 27th of September. What I'm going to show you now is the before and after when Cast AI was activated for this cluster. Cast AI is in full force. Our AI engine is right now monitoring and managing this infrastructure. And you can see the up and down here is what that means. It is optimizing this cluster right now. But let's see what happened before and after. So this cluster was onboarded in January, around the 20th. So I'm going to show you before, so from the 10th of January to, let's say, the 8th of February. And you're going to see the impact of turning on Cast AI. And here's the impact. We turn on the engine on the 21st. Wow. Before, this client was spending $1,000 per day, and that's AWS. They would be the same on the other two cloud providers. When we turn on the engine, that became 387. It's 65%. You can see it's instantaneous. Like you turn it on, it happens. They turn it on at the end of the 20th. So 21st is a full day with the AI engine in full force. But let's see why and why was this cost reducing? So there's a few things you can see here. First, you see there's this blue bar. This is darker blue that comes the 19th, the 20th, 21st. Darker blue is the fact that the AI engine said, well, there is some containers that are very stateless, very highly duplicated. Great. Let's put them in Spot. Let's use the low-cost instances that is available right now on AWS. You see this number, the blue number, is never the same. It changes all the time. It depends on the amount of duplication or the amount of containers that are compatible with Spot. So that's the first thing the engine does. Why is Spot great? Because it's 70% cheaper than on demand. Fantastic. You see there is this column called fallback. It means, well, if there is no Spot instance, then I will fall back to on demand, but it did not happen. So from the 21st of January to the end of the month, you can see we were able to supply all the Spot instance that was compatible with this application in real time. And we continue to do this today. But there's something else that happens. Let's zoom in on the 21st of September. We have the data here. So I'm going to show you, as 21st of January, sorry, here. So before Cast AI, this is the number of CPUs that were provisioned for the cluster. It's about 850, 860, 900. The minute we turn on the engine, that number went to 437. It was divided by almost half. And it's not that the application is half slower. It's in fact because there were a little bit more than 400 CPUs in these clusters that were absolutely not used. So you combine these two things. I reduce the amount of CPUs by almost half. I start to use low-cost instances. I get 65%. The difficulty is to do this in real time. But when you do it, this is the kind of impact you get. And this is fully automated, right? There's no place where I say, oh, this container put there. Oh, this machine shut down. No, the engine made those decisions in real time and instantaneously. And then once it's there, it continues to stay there. But if you look at the last 30 days, so now we go back to September, October, you see this blue, dark blue and light blue, it's still in full force. This is today. So that's an example of before and after, and that's what the engine did. But I want to show you something a little bit more with more details. Saying that 400 CPUs are not used is actually very difficult to do because that's an average. That may not be the same percentage of not used CPU right now as it was 5 minutes ago. So I made this, let me put a slideshow. This is an example, this 24 hours example of utilization of CPU for a cluster. It's actually requested amount of CPU. What is in yellow is what you need to run this app. This is 24 hours. This is very typical of business to business. At night, your customers are sleeping, so they use less of it. Then they wake up, they go for lunch, then they continue to use it in the afternoon, they go back to sleep. The blue line is what the cloud provider was supplying to run the yellow line. The blue line is the amount of CPU provisioned, so what you pay. The yellow is the amount of CPUs that you need. The difference is your waste. This is the best Kubernetes can do by default. This is what an AI engine does. And you see the big difference. The engine says, well, at night you don't need, therefore I don't provision these machines. You don't need them. Then you're waking up, you go up, great, I'll go up with you. I'm following the curve. At night, oh, you don't need it anymore. I delete these machines very, very fast until the minimum that is here. You see the difference between left and right. This is what right sizing looks like for almost any Kubernetes clusters that we see. We like Kubernetes, we like containers because you can scale them up and scale them down. What we do, we ensure that what you provision is what you need. And we do this in real time. And what you see between the left and the right is a typical example of using smart autoscaler or AI-powered autoscaler that has been trained to look for efficiency. And then you can see it's a real-time engine. This client wanted 20% headroom. So they wanted the blue line to be 20%, about 20% higher than the yellow line. This client doesn't do this anymore because you see, we follow it in real time. Like there is this 1 p.m. Increase here by 500 CPUs. We actually were able to follow it exactly. So there are places where blue and yellow collapse and you can see the difference between them when you unleash the power of this engine with no headroom. So that's what the kind of impact we have. And I have a few others to show you on specific AI companies. So recently, a lot of AI company came to us, meaning company that do a lot of machine learning training or inference. They come to us because for them, paying GPU costs about 10 times more than a CPU. So these training are extremely expensive, and any percentage you can optimize from this training can be a huge amount. So this is the before and after for machine learning training. This is an example of a training. You can see it because it goes from 0 to 10,000. This is a mix of CPU and GPUs. You can imagine how expensive that is for 4 hours. Then at the end, you go back to 0 because your training is essentially done. That is typical of how that works. A small machine learning engine that requires a huge amount of CPU. You notice that the yellow line is way, way below the blue line. And this is what we do. We make sure that we supply what you need, but we immediately stop it after you stop needing it. This is an 89% efficiency between before and after. This is a screenshot of Grafana for amount of CPUs between request and provision for this cluster. I have a lot of examples like this. This is another one. 6,000 CPUs, 4 hours. The same thing. A huge, like this is like more than half waste on any attempt they have. And this is after. So you see these examples, they are really the story, right? They are really the reason why using automation make this happen. And again, I want to say something, because a lot of people are telling us is, oh, it's not that you were not able to do it. It's just that it was impossible to try to do it with your hands, or I mean, with the traditional recommendation tools or the traditional cost monitoring tool. You need to think of using automation, because these problems you solve are really hard problems to solve, and they are non-linear, right? Imagine this: when you need to add a new node. This node needs a GPU, but you don't have exactly the CPU you need. But it doesn't matter, because it's the GPU that is more important. Or maybe it's the memory that is driver. You see, so this is a non-linear problem where you tell the AI engine, I need all these things. And the engine says, okay, great, I'm going to go figure this out and select the box that fit into the minimum variables that you gave me in terms of CPU, type of GPU, type of memory. That's why the automation is so important. And that's why the impact of automation is so visual for our clients, for users.
Thanks for showing us that. That would pretty incredible savings. I mean, it would be a no-brainer for, I guess, for people with the amount of money that they're saving with the AI automation, that it would pay for itself in no time, right?
Oh, I have never, this is my third startup. I have never seen such a rapid adoption of our kind of tool. And, I'm one of the founders of the company, so I lived through the beginning of it until today. And for a long time, we thought we would see a lot of cloud native companies using this, because they tend to use more cloud native tools like Kubernetes. And we were very surprised, like Fortune 500 are all using our tools and product. And it's interesting to see the level of adoption and the level of sophistications for enterprises that you would believe would maybe not be using the same things that the startup in Silicon Valley is doing. This level of adoption of automation is across the board, with people have the exact same culture of wanting to make this efficient, speak the same language, the DevOps language, and are very similar in the type of problems we try to solve. Whether it's a small startup, super cool startup developing some great AI engine somewhere in the world, or the largest steel manufacturer that is using Kubernetes for all the IoT or variable or monitoring that they have in the factory. And that applies the same way, and the adoption has been incredible.
Well, like Brian said, thank you so much for that demo and for taking time out to talk with VMblog. Obviously, we're highly recommending everybody who's going to KubeCon to come by your booth and check it out in person. But if folks can't go to the trade show, where's the next best thing for them to go to learn more about some of the things we talked about today?
Oh, it's easy. You can go to cast.ai. You can create a free account, and you can use all the platform and try all the platform. And the free account has all our features included.
Well, great. Well, thanks again. We appreciate you talking with VMblog, and we hope you have a great and successful KubeCon.
Thank you, guys.